The Ellen Degeneres campus of the Dian Fossey Gorilla Fund is located in Kinigi, Rwanda, and was designed by Mass Design Group for the Dian Fossey Gorilla Fund organization, which is a mountain gorilla conservation and research group. It was completed in 2022. This location is within the Virunga volcanic mountain range, which is prime location for the mountain gorilla observation and habitats and hosts many of the different volcanoes in the Rwanda area. This project takes advantage of the connection to the outside and inside to provide natural ecologies and take advantage of the natural resources found on site. This campus was designed to house many of the students, to host research, classrooms, a library, and outdoor space for this conservation work. Rwanda's climate consists of timber, bamboo, pozanic cement, and local stone, which allows for sourcing of materials to aid the natural environment and lower costs of transportation. Pine wood and bamboo are locally found in Rwanda. These sources are found regionally. They are easily obtainable and have the longevity to withstand Rwanda's climate. The design uses it with the intentions of designing with a material that will last, is renewable, has high strength, and is flexible in case of volcanic shifts. As shown in the map, it is locally sourced from the northern part of Rwanda. Similar to timber, bamboo has renewability, flexibility, and strength. It is used in this project because it is easily sourced and it mimics the habitats that mountain gorillas are found in. Concrete with pozzolanic additives is very commonly in Rwanda as well. Pozzolanic additives are incorporated crushed volcanic stone found on site and added onto concrete mix to create strong structures. Using volcanic stone in design allows for the inclusion of site materials to be used on the project, as well as to increase density of concrete and its compressive strength. Another way that the volcanic stone around the site is used in the design is that they're able to carve out volcanic stone pavers and put it into the landscape. To understand why there was a need for the conservatory group to be designed in Rwanda, we have to understand the Dian Fossey Gorilla Organization, which was established in 1967 in hopes to aid the gorilla populations in Africa. In 1980s, there was a big decline of gorilla population due to the human invasion into their habitats. Researchers had classified them as critically endangered. Then, in 1991, gorilla monitoring began, and groups set out to search and research how many populations of gorillas were nearby and how to maintain their habitats. In 2001, they began protecting these gorillas and hosting research to maintain close watch to their habitats. In 2019, Ellen DeGeneres was inspired by the work of this foundation and was able to fund and break ground for construction for a campus right in Rwanda near their habitat. In 2022, the opening of the campus led to more awareness and more aid, and the need for more aid for mountain gorilla habitats. And today, the work that has been made to aid the population has been affected greatly. The numbers are being restored and numbers have increased since their extinction. Their population has now shifted to just endangered from before critically endangered. Rwanda's climate can now be shown into and understood with different charts. The first one is the sun shading chart, which can be used to explain the comfort levels that come from the sunshade throughout the year. Because the site is located near the equator, the sun comes directly from above all year round in similar locations. Within June, March, and December, they are directly from above, which allows sunlight to come in but doesn't create the need for long overhangs. The daylight intake chart is another way that we can study the temperature in Rwanda. It can explain how much daylight is taken in every day throughout the year. Because the location, again, is near the equator, a lot of sun is very predominant in the area. So, this means the amount of daylight all year around is the same, which creates the opportunity so that energy therefore light is less consumed during the day and more daylight can enter in the interior spaces in the design. The temperature range chart shows the comfortable temperatures throughout the year. The temperature around year-round in Rwanda is really comfortable, with not much need for electric heating, or electric cooling, which also allows the opportunity for many openings and windows to invite light in. Some of the different sustainable features that are found throughout this project include the use of green roofs, transom windows, central oval clerestories, sun-protecting overhangs, local vegetation, polyatlantic concrete walls, extracted volcanic pavers, vegetation windbreak walls throughout, and infiltration basins. As explained throughout the analysis of a region, having these elements like central oval clerestory and sun-protecting overhangs and transom windows allows for inside spaces to be illuminated by daylight and less need for electric light to be used inside. Another different use of the elements throughout the design that create sustainable features is the use of the natural resources, as we can see with the green roof and the local vegetation, the volcanic stone pavers, the polyatlantic concrete, and the use of the infiltration basin. Predicted water performance in the area. Since the campus has been designed with rainwater in mind and erosion prevention, the design is designed so that the water that falls through the roofs with the rainfall every year can be connected into underground tanks, which are then used for the building's bathrooms. This is used as harvesting water for less water consumption throughout. The site uses a lot of its waters from harvested resources and uses the water runoff to be redirected into infiltration basins. For predicted energy performance, the building is all electric but uses a lot of strategies to significantly reduce energy usage. By using a lot of the previously mentioned elements, a lot of passive design strategies are achieved. In its 2030 commitment towards energy reduction, the design was able to meet 80% reduction by 2020. Energy reduction has been measured to 92%. The benchmark of similar buildings around the area was 183.8 kBTU per square surface per year, but the building was measured to 14.6 kBTU square feet per year, with a predicted embodied carbon intensity of 59.3 kg carbon emissions per square feet. This campus creates a lot of opportunity for research, education, and environmental immersion. Its location in Rwanda allows for many different strategies that are not common, especially in the western part of the world. Its nearness to its equator, volcano, and the available resources throughout allow for these different strategies to take place. The campus was designed so that it feels like you're immersed into the landscape. Through the addition of green roofs, the materials, the hills, the vegetation, the concrete, and the windows, it creates a sense of being part in the natural habitat, as well as its use of resources to design an energy-efficient design. This makes it a unique building. So, taking all into consideration, the reason why the building was founded to host this research for gorilla conservation, the materials used throughout the site, the energy-efficient designs, and the immersion into the landscape all create a very unique building in Rwanda.